The definition of a radian is if you take a circle and you draw in a radius, a radian on the circle is the angle that's created such that if you take the radius and stretch it out across the circle, this would be 1 radian. So it's a measurement of an angle. So usually we've been doing degrees, but a radian is a measurement of an angle. So if you took this same radian and stretched it out around the circle, it would be a little over 6 radians. So all the way around there's over 6 radians in a circle. So most of the time we talk in terms of radians of pi. So remember, pi is about 3.14. So all around the circle is about 2 pi radians. So that's why 2 pi is about 6.28. So all around the circle there's over 6 of these radians. So to convert between radians degrees, pi radians equals 180 degrees. So I'm going to use this ratio when I'm converting, if this is in degrees to radians, write each measure in radians. What I'm going to do is I'm going to multiply by pi over 180 because pi radians is equal to 180 degrees. So I'm going to divide the 45 by 180, reduce that. 45 goes into 180 4 times. So this is 1/4 pi. So I'm going to write this as pi over 4. So if I'm converting degrees to radians, I'm multiplying by pi over 180. So I'm going to multiply this by pi over 180, and I'm going to reduce 90 goes into 180 twice, so this is actually pi over 2. So negative 220, I'm going to do negative 220 times pi over 180. And I'm going to reduce this. I can divide 22 and 18 both by 2. So it's going to be negative 11 pi over 9. And I'm going to multiply 130 times pi over 180. And 135 and 135 and 180. I can divide both of these by 45. So if I divide this by 45, I get 3. And if I divide 180 by 45, I get 4. So it's 3 pi over 4. So radians are usually expressed in terms of pi, but it doesn't always have to be. Write each radian measure in degrees. So in this case, to convert it to degrees, I'm going to multiply it by 180 over pi. So the pi's will cancel out, and I'll get 180 degrees. So pi is 180 degrees. I'm going to multiply this times 180 over pi. So the pi's cancel out. 2 times 180 is 360 degrees. I'm going to multiply this times 180 over pi. So to me, it's easier to divide 180 by 6 and then multiply it by 5 than to do 5 times 180 and divide it by 6. So 180 divided by 6 is 30. 30 times 5 is 150 degrees. And for the next one, I'm going to do the same thing. So I'm going to do times 180 over pi. The pi's cancel out. It's easier to do 180 divided by 4, which is 45, and then multiply it by 3, so it's negative 135 degrees. So this next one doesn't have a pi in it. It's okay. So you're still going to multiply it by 180 over pi. So this is going to be 360 divided by pi. So the directions read round to the nearest degree if necessary. So 360 divided by pi is going to be an irrational number. I don't have my calculator on me right now, but I would divide 360 by pi and get the decimal. Just like we did sine and cosine and tangent of degrees, we're going to do the same thing with radian measures. So I'm going to do a couple of these. So first what you're going to want to do is convert it to degrees. I'll show you how to convert it to degrees, and I'll do a different video on the unit circle. So this is going to be, cancel out the pi's, 180 divided by 4 is 45. 45 times 5 is 225. So really what you're doing is the cosine and sine of 225. So 225 is going to be in this quadrant right here. If I draw the angle, and it's going to create a 45, 45, 90, because 225 is going to give you a 45-degree angle. So remember, with a 45, 45, 90, you're going to have the side lengths of root 2 over 2, root 2 over 2, and the radius is 1. So if I find the cosine of 225, I'm finding the x-coordinate. So the x-coordinate is, I had to go back, I had to go to the left, negative, or I have to go to the left, root 2 over 2. So the answer is going to be negative root 2 over 2. The sine of 225, or 5 pi over 4 actually, is going to be negative as well. So it's going to be negative root 2 over 2, because I had to go down to get this. So now I'm going to do 11 pi over 6. So first I'm going to convert it to degrees. Eventually I'm going to want you to know where 11 pi over 6 is, and I'll do a separate video on that. So I'm going to multiply this by 180 over pi. Pi's cancel out. 180 divided by 6 is 30. 30 times 11 is 330 degrees. So I'm going to draw my 330-degree angle. Start right here, go around, and almost 30 degrees. So this is, or 30 degrees short. So this is going to be a 30, 60, 90. So the short side's 1/2, and this is root 3 over 2. So I'm going to find the cosine is going to be the x-coordinate. So the cosine of 11 pi over 6 is going to be the x-coordinate, which is root 3 over 2. The sine of 11 pi over 6 is going to be the y-coordinate, which is a negative 1/2, because you're going down a half. Okay, and then the other two are similar, so you could convert to degrees and then make your 30, 60, 90 or your 45, 45, 90. Okay, second part, arc length. So arc length has to do with the circumference of the circle. So a whole circle has an arc length of 2 pi r. So the formula to find the arc length is s times theta. So s, weirdly, is the radius, and theta is going to be the measure of the angle in radians. So to find the arc length, you just have to multiply the radius times the radians. So you might have to make sure that you're in radians first. So find the arc length of each radius and angle measure. It's given in radius. Give the exact value, and then round to the nearest hundred. So I don't have my calculator on me, but you could put it in your calculator. So this is just going to be radius times radians, 11 pi over 6. So I'm going to reduce 10/6 to be 5/3. So the answer is going to be 55 pi over 3, and we have centimeters, because it's a distance. This one is just going to be 12, because that's my radius, times 4, and that's in radians. So it's going to be 48 centimeters. Example 5, find the arc length given the diameter and in degrees. Give the exact value. So diameter, remember, is twice the radius. So I have to convert these degrees to radians. So it's going to be radius times radians. So 60 degrees is going to be, multiply it by pi over 180. 60 divided by 180, or 180 divided by 60 is 3. So it's going to be pi over 3. So my diameter is 10, my radius is 5. So it's 5 times pi over 3, which is 5 pi over 3 centimeters. Okay, the second one, I have to convert these degrees to radians. So it's 100 times pi over 180. I can cancel out the zeros and reduce 10/18 as 5 pi over 9. So my radius is going to be 4. So 4 times 5 pi over 9 is going to be 45 pi over 9 meters. Okay, and the last one, find the length of the minor arc. So if you might remember from geometry that minor arcs are less than 180 and major arcs are greater than 180. So this would be the major arc. Give the exact value, then round to nearest hundredth. So I'm going to do the exact value first. So it's going to be arc length equals radius times radians. So my radius is 2. In my radians, it's already given in radians, is 2 pi over 3. So the answer is going to be 4 pi over 3 units. And then if I have to round the nearest hundredth, what I want to do is I want to put 4 pi divided by 3 in my calculator and round to 2 decimals.